Good morning. I think my mic works, hopefully. Hello, nice to see everyone today. We're very excited to get this conference off and running. I've got some great speakers to present today, and we will get going momentarily. So first of all, I'd just like to introduce you to our morning session, which is Food Safety Hot Topics, Aflatoxin Factors, and MOSH and MOAH. I'll be the moderator. A couple of quick notes that I just want to cover before I get distracted here. We have continuing education units available for 3 of today's presentations, so check your program for that. I'd like to, let's see, okay, I do have a monitor down here. It's my job to make sure everything works before we bring our presenters up here. So let's see, team in the back, there we go. There's the first slide. There's the CEU sessions, which I'm sure you have in your book. And those are our medal sponsors. So we want to, of course, thank our sponsors for keeping this program going. The Food Truck Village will be open today 11 to 2 and located at the West Lobby Plaza. And the opening reception begins today at 3:30 at the Almond Conference Expo. So special note, if you introduce yourself to a board member, they're each holding a stack of drink tickets. So hopefully they'll share those with you. Okay, let's get started. So quick introduction myself. My name's Brian Dunning. I'm with ShoEi Foods. I've been involved in the Almond Quality Food Safety Services Committee since 2007. And amazingly enough, when I joined the committee in the industry in 2007, we were talking about aflatoxin. And that was a serious issue, especially related to our exports. And today we're still talking about aflatoxin and some of our latest research. So we'll look forward to sharing that. Have 3 speakers today, both Tim Birmingham and Guangwei Huang from the Almond Board of California. But first, I'd like to introduce our researcher that's doing our latest research, aflatoxin research, today from Purdue University. And without further ado, Dr. Gizachew, come on up, and I think we should have your presentation ready to go. Welcome.
Thank you.
And I already missed the first slide, so connecting the dots, you're all ready to go.
Okay, yeah. Thank you. All right, thank you for inviting me to present some of my work on aflatoxins and fungal growth on California almonds. Let me see, how do you go forward?
It should be the green
okay,
button.
Okay.
And then you have
fantastic. All right, so for those of you who are new to aflatoxins, they are produced by some fungal species, and aflatoxin is one of the mycotoxins that are produced by these fungal species as secondary metabolites. And these secondary metabolites are produced by these fungal species because either to decrease the fitness of other organisms or to ensure their survival and reproduction. And some studies show that they also play a role on regulation and sporulation and so on. So the focus of attention is on 6 groups of mycotoxins. And the reason is that they really pose serious health threat to both humans and animals. And of these, aflatoxin is one of the most toxic substances. That's my topic as well in our current research. So I'm not going to details of the others, so I'm going to straight go ahead and talk to aflatoxins. So what are the harmful effects of aflatoxin. One of the aflatoxin chemical is the aflatoxin B1, which is a known carcinogen, causes liver cancer. So a lot of studies have shown that. And also a growth impairment, depressed immune system, decreased in appetite, both to humans and animals. So the aflatoxin is produced by two main fungal species. These are Aspergillus parasiticus and Aspergillus flavus. So parasiticus one that you see on plate is a greenish color, and the yellowish green one is the flavus. And here, just to give you an example, that they infest crops either pre-harvest or post-harvest. They are widespread, and especially crops such as they grow on corn, nuts, and oilseeds. We have studied before quite a bit on oilseeds. So because of their also widespread, they are the most serious concerns when it comes to food safety. Without me being a chemist, I like the chemical aspect, without really going to a lot to the details of the chemicals, but just to show you the four main groups of, let me see if I can use this, I don't know if you can see the difference, just to show you the difference between, for example, the aflatoxin B1 and B2. There is a double bond here, and there's no double bond. And so that also affects the toxicity. So B1 is more toxic than B2. If you look at G1 and G2, also there is a double bond somewhere. Let me see here. There is a double bond here, no double bond. So the difference between B1 and G1 is here is 5-membered ring, and this is 6-membered ring. So all these four chemicals, to some level, they do have toxicity, but B1 being the most toxic one. And also, when B1 is ingested by animals or humans, it gets metabolized and then excreted through milk, either breast milk or cow milk. And so when it's consumed, especially by children, the metabolized aflatoxin, which is M1, is toxic enough to cause some serious concerns when it comes to children's health and anyone, in fact, for that matter, consumes milk products. For that reason, countries have put regulations. And the recent data I have is that the Food and Drug Administration limits all products for humans, except milk, is 20 parts per billion. And for M1, which is, as I said, the metabolized form of B1 that is present in dairy products, is 0.5 parts per billion. Actually, there is even stricter regulation in other parts of the world. So that affects, obviously, global trade because of these regulations. So the main factors that affect fungal growth and aflatoxin production is temperature, water activity, the incubation period, and the types of kernels and fungal species. We are set to do determine the optimum temperature and water activities that determines the fungal growth and aflatoxin production on almond kernels. And also, what are the different types of almond kernels? How can they be affected by different temperatures and water activities? Other factors that include for how long can we incubate the almond kernels and how much they are affected. So we were set out to determine these factors. So we adjust the temperature between 20, 27, 35 degrees Celsius, a range of water activity, and we wanted to study also in-shell and shelled and split kernels and the two types of fungal species, the main ones, the Parasiticus and Flavus. So as you can see here on the plates, the greenish one is a Parasiticus and white greenish is the Flavus. So they're plated on what we call PDM medium, and then we take and do spore suspension and inoculate the almonds at required water activity and adjust temperature. And as you can see here, this is on a split kernel. This is how it looks like when it's coming out of the incubation. So we do homogenize after a culture, and then we use immunoaffinity columns to purify, and we do using a chromatography technique to analyze the different aflatoxins. So here I'm going to show you some of our results. The in-shell kernels, for example, when we studied that, we noticed or we observed that I need to go back. We didn't see any fungal growth at 0.65, 0.8, 0.85, 0.99 water activities. And also no aflatoxin production under these conditions. However, we saw some fungal growth at 0.9 and 0.95 water activities. As you can see, by the way, this is the Aspergillus parasiticus right now. You see the green spots, that is the Parasiticus. And we also saw some black spores here, and we think it could be a Rhizopus stolonifer that is also growing there. And I'll discuss that a little bit. Seems like it could also interfere with the growth of the Aspergillus species. And when we looked at the shelled whole kernels, at 20 degrees Celsius, we didn't see any growth at all this range of water activities. But however, at 27 degrees Celsius, at 0.9 and 0.95 water activity, we saw some growth initially, and then the other funguses, like probably we assume that's Rhizopus stolonifer or Aspergillus niger, start to dominate, and as you can see, these black spores are those two fungal species probably. So we also saw at higher temperature the growth of the Parasiticus on the whole kernel, shell whole kernels. Now we said, okay, how about, okay, can I move it? It's not moving. Okay, thank you. So, and then we looked at the split kernels. When it comes to the split kernels, again at 0.65 water activity, we didn't see any fungal growth. However, we saw a significant high fungal growth at a range of water activities, 0.8, 0.85, and so on. And as you can see, this is a green stuff is the parasiticus grows. This is as an example at 27 degrees Celsius and 0.9 water activity. So just to show you comparison between these different types of kernels, in terms of, is that as you can see, the in-shell one, the green is 0.95 water activity, red one is 0.90 water activity. So you can see the in-shell and shelled, they prefer those two water activities. So we incubated it for 10 days. And the split, as you can see, it grows very high at a wide range of water activities. So we incubated it even for a longer period of time, for 20 days. Then it started to, the in-shell and the fungus on the in-shell and shelled ones kind of start to diminish. We suspect that, but when we looked at it, these Rhizopus stolonifer and the Aspergillus niger started to grow faster than the Aspergillus parasiticus. It seems like they're competing, and the others are growing faster. Even for the split, still we see high growth, but it's a little bit diminished. And we continue growing it for 30 days, and as you can see, the in-shell and the shelled ones, the parasiticus start to, or growth is diminished, and so is the split, but still the split ones, on the split, the parasiticus grows much better. Now, when it comes to water aflatoxin, so far what I told you was the fungal growth. And so now when we look at the aflatoxin, so you can see we are looking at only at 0.95 water activity, because the fungus produced only at 0.95 water activity the aflatoxin. That's only goes on the shelled and in-shelled kernels. So as you can see here, the red ones is on the split kernels, significant amount of fungus was produced, and the blue one is the in-shell and the yellow one is shelled. So we also think still this variation comes for the shelled and in-shelled due to the presence of the other fungal species competing over the whatever nutrient is there. So while on the split kernel, as you will see here, when I'm trying to show you a contour map for split kernels in 10 days incubation, you see the red one is high fungal growth, and as you can see, the x-axis or this horizontal axis is water activity, 0.9, 0.5 range, and even at a higher temperature here, even at lower water activity, we see some growth. So if we increase the incubation period, as you can see now here, the aflatoxin production is widened by even with a wider water activity. So even at lower water activity, we can see in high temperature, we see some high levels of aflatoxin. So it seems like as they stay longer, the high temperature and low water relatively lower water activity, like 0.80, is a preferred combination of conditions that allow the aflatoxin production. And we stay longer, as you can see, even the lower water activity, it's as low as we went, which was 0.80, we can see at high temperature and even lower temperature, high level of aflatoxin. And so, okay, thank you. High level of aflatoxin. And so clearly the split kernels, a wide range of aflatoxin, water activity conditions allow aflatoxin production, and as we increase the incubation period, it seems to favor even the lower water activity and high temperature conditions. So we also start to work on the flavors. So far what I told you is, remember that there are two fungal species. Main fungal species are Parasiticus and Flavus. So because of there's so many variables, so we first studied Parasiticus, now we start to look Flavus. Now when it comes to Flavus, and again, high water activity and low water activity doesn't seem high, means really high, like 0.99, doesn't seem to favor growth of the fungus. And but as you can see, at 27 degrees centigrade and 0.9 water activity, we can see some fungal growth of Flavus for all the in-shell and shelled and split kernels, as you can see it on the picture. So this is where still doing analysis of aflatoxin and fungal growth on the flavor. So this work is in progress. So as to summarize my results, so both Parasiticus and Flavus show no fungal growth on in-shell, shelled, and split almond kernels at 0.65 water activity and temperatures of these three. We waited as long as 90 days now. When it comes to Parasiticus, it shows some growth in shell and shelled at these two water activities. And the fungus also shows high growth at 0.8, 0.85, and 0.90, and 0.95, and so on the split kernels. So total aflatoxin production by A. Parasiticus on in-shell and shelled is limited only at 0.95 water activity. On the split, a wide range of water activities allow the aflatoxin production. The optimum conditions is at 0.9 to 0.95 water activity and 20 to 27 degrees Celsius for a Parasiticus to grow, to produce on split kernels. And high water activity for both A. Parasiticus, like 0.99 water activity, is not favorable. I think mainly it seems like Rhizopus stolonifer or Aspergillus niger tend to grow faster and dominate the growth on the kernels. So as we go further, our progress is on looking at what happens if we even wait an even longer period of time with low water activity. We're just trying to determine what water activity as low as, and that allows fungal growth and aflatoxin production. And we also want to, now we know that at 0.80, both aflatoxin and fungal growth can happen. So how about if we lower further, so we're trying to see the limit. So we're going to do the 0.75 water activity as well. And so we plan to do aflatoxin analysis of A flavors, so which we are doing right now. And the statistical analysis also can help us the relation between the various temperature and water activities, incubation period, and so on. These variables, how do they correlate to each other to see the optimum conditions? So we plan to do that. So the elephant in the room is that we all are talking about climate change. So would that even worsen the conditions of aflatoxin, which we think it might do that, and for reasons that I mentioned here. We obviously might see some increase in temperature, increased presence of insects that damage crops, change in frequency and amount of rainfall. So we have to be vigilant when it comes to aflatoxin contamination of crops. So we suggest that it's good to see the impact of these stolonifer and Aspergillus niger that seems to come with the almond that interfere with the parasiticus, and their role and cross interaction would be nice to study. And we also like to see if there are naturally damaged kernels to see how the fungal growth and aflatoxin happens. And blanched almonds also is quite interesting. So people, we see it in the market as well, so it would be interesting to see the fungal growth and aflatoxin production on blanched almonds. We also plan to, recommend to isolate, if possible, either from the tree, almond tree, or soil, and see the fungal growth and aflatoxin production. So finding the isolate would be quite interesting to do that. And also after that, maybe what are the conditions pre-harvest and post-harvest, and how can we mitigate if there are some issues with aflatoxin on almonds. So I would like to acknowledge the funding by the Almond Board of California, my assistant Barbara Soni, to do some of the work when I'm very busy with teaching. And so thank you for listening, and if you have any question, that would be great.
I think if it's okay, you stay available. We'll entertain questions after the presentation.
Absolutely.
Okay.
Yeah, absolutely.
All right, we'll do that. Thank you very much,
Yeah.
Dr. Gizachew. You'll be available. Yeah, you can please have a seat. Yeah, we'll keep you up here while we finish off the panel. Next, I want to introduce Tim Birmingham, my staff representative for the committee, and who I've been working with for the past 17 years. And as we've embarked upon this research, Tim has compiled it all and put all the pieces together. So talk a little bit more about how that impacts our industry and our practices. Welcome, Tim.
Thank you, Brian. It's great to look out and see so many faces here. Brian and I were joking, about filling up this room a little bit earlier, and I think we've almost filled this up. I don't know if we've ever had a food quality and safety session here at the conference that's had so many people, especially the first session of the day. So thank you all for joining us. And thanks, Dr. Gizachew, for that great information. I'm going to talk a little bit about how that relates to some of the questions that we're trying to answer with aflatoxin here in a few minutes. One of the big questions we get is what happens during transit? And the work that he is doing right now is really going to help us to put the nail in the coffin as far as telling our story that during shipping we don't have concerns related to aflatoxin growth, mold growth, and aflatoxin development. So we're really excited about the work that he's doing. But just to kind of ground us all in aflatoxin and what we know about aflatoxin, I wanted to show this slide here, and some of you have probably seen this before. But this just really tells a story about the correlation of aflatoxin with insect damage or serious damage. This slide, or the graph on the chart on the right, it's a combination of a study that we did looking at 50 different almond lots, where we sorted these almond lots into different grade factors. And what we can see here is that the insect damage accounts for about 7.2% of the weight for the study that was conducted here, but that contributes to 76.3% of the aflatoxin mass. So from those 50 lots, we're finding in that 7.4 or 7.2% insect damage fraction, we're finding 76.3% of the aflatoxin mass. It's telling us that's where the majority of the aflatoxin is. We can also find it in the other defects. So, a lower concentration by weight, 1.5%, but that contributed to almost 12% of the aflatoxin mass. And then you find it in the mold. We don't find a lot of moldy nuts, but we do have a study. I'm going to show some data here in a second showing that, when you have mold, when you see mold in nuts, you can, find aflatoxin in those nuts as well. The little navel orangeworm photo you see here, those are in the background, little white fuzzy dots there, those are mold spores. On the little filaments from the navel orangeworm, you can actually see the mold spores clinging to the filaments. Navel orangeworm is indeed a vector for the mold, for Aspergillus flavus and parasiticus, and it can move it throughout the orchard. That graph on the left of that little photo there shows you that as you increase the number of feeding sites on an almond, the number or the levels of aflatoxin increase as well. So it is indeed a vector. When it munches on the nut, it actually can create some different changes to that nut as well and allow the proliferation of the mold and aflatoxin development. Let's see here, how do I move this forward? All right, so I'm going to show you some data here in a second, but this is I'm going to show you the summary before I'm going to show you the slides. But what we've done here over the last several months is we've started to collect reject samples. We're looking at insect damage, and we wanted to try to divide the insect damage or the damaged nuts into different categories by insect type or damage type, and then evaluate the level of aflatoxin. One concern that has come up over and over again is what is the aflatoxin level in pinhole damaged nuts? And so we were trying to really look at that as well as some of the other different types of damage that we see to see if there's one type of damage, one type of insect damage that may be contributing predominantly to the aflatoxin issues that we see. So we collected some rejects. We got reject samples from USDA. We also received some reject samples from industry over the last few months, and we sent these off to the lab for analysis. In this study, what we saw is that those nuts that actually had visible signs of mold, that's where we found the most aflatoxin. So moldy and rancid nuts, followed by insect damage. Then we had some of the other rodent-type damage where we found aflatoxin. So when you're disrupting the skin surface on the almond is when we found the aflatoxin, and then some of the other defects. The rejected good meats, so in the reject samples that we collected, we were able to pull out some good meats. We found less aflatoxin in those. And then we even found in the pinhole damage, we didn't find very much aflatoxin, which we were surprised. We thought that we were going to find a lot of aflatoxin in pinhole, and maybe this was our issue, is that we were having trouble with sorting out pinhole, but we weren't able to find a lot of aflatoxin in this study in the pinhole. We're continuing this work. We are gathering more samples. We are further analyzing, and we're going to be packaging this up into a white paper here at some point once we have a little bit more data. So let's look at the data. So this is really kind of hard to digest here, I know. What I want you to focus on is the bigger bars towards the right. Those are the moldy nuts. So the ones where you see those high-level bars, that's when we found mold, we found aflatoxin. To the right of that is the pinhole. And you can see there's a line below the 1. This is a logarithmic scale of aflatoxin. So below 1, we start to get into the level of detection. We didn't find aflatoxin in the pinhole except in 2 out of the 13 samples. So we found it, but not widely like we thought we would. And then some of those other samples we found in the rodent damaged nuts, we found some aflatoxin. So when you're disrupting the surface, You can have contamination. We don't know if it's a cross-contamination that's happening or the rodents are involved in serving as a vector, but we did see some aflatoxin there as well. This is for total aflatoxin, and then we also, when we look at it by just B1, it's a similar pattern here. So a little bit surprising when we saw this. Again, the pinhole, we thought maybe we would see more aflatoxin. Again, this is only in 13 samples. We're going to continue to analyze here. For the pinhole, it was only 13 samples. We're going to continue to gather more data, and we'll be sharing this, at a future date in a more scientific paper. All right, so now I want to get into the post-harvest, the moisture control, and really kind of piggyback on the work that you just saw. So when we look at moisture, and we talked in the previous session about water activity. This chart on the right, and some of you have seen this before, this is an almond isotherm. And so this is looking at the relationship between water activity and moisture for a number of different varieties. You can see this curve. On the x-axis, you have water activity, and on the y-axis, you have moisture. So if you expose almonds to a specific water activity, give it enough time, it will equilibrate to a specific moisture. And it's a little bit different for different varieties, but they generally follow the same pattern. And so you can see here on the green bar, or the green lines that I overlaid on this graph. I'm sorry, I can't use the pointer so you guys can see. But for a water activity of 0.5, that equates to about a moisture of 5%. And most almonds are shipped below 5%. So the data that we just saw, the blue bar here, showed that less than, or at a 6.5 or 0.65 water activity, which equates to about a 6.5% moisture, we didn't have any mold growth. So that's good. We know we're not shipping, in most cases, we're not shipping almonds of that high of moisture. Everything is going to be less than 5% moisture. But during shipping, things can change, and potentially you can pick up moisture given enough time. What we don't want is we don't want almonds to reach into that threshold where we know we're going to have issues, and that's around that 8%, 0.8 water activity, which equates to a 9% moisture. Now, if we had 9% moisture almonds, we know they're going to be getting moldy. So that's really, if you open up almonds and you see that they're moldy, you probably had a little bit of an issue. Traditionally, or in the past, though, we thought that that was really kind of that threshold for mold growth and then aflatoxin development. What the work that Dr. Gizachew just showed us is maybe on, at least for the broken almonds, maybe the water activity, the minimum water activity for aflatoxin development, it might be a little bit lower than that. So that work is still ongoing. What we really want to do as well is determine as you get into some of those marginal moistures and water activities. So maybe as we start to get up above 7% on the moisture, are we seeing any issues? And we don't think we will see any issues, but we want to kind of fill in those blanks as well. Now, how can we use this moisture or water activity to really help us understand, what's happening during shipping? What you see here is that URL link. That's actually a tool that we have on the website that was developed by Dr. Paul Singh at UC Davis. We can actually plug in different conditions into this model, this tool, so we can tell it, what the starting moisture of the product is, what the relative humidity is during shipping, what the temperature is, and then it will predict the moisture over time. And what you see is, you get a pretty rapid rise in moisture depending on the environment it's subjected to. The almonds are going to pick up that moisture, but they're only going to reach a certain point, and then they're going to level off. And typically, the moisture that they reach is going to be a little bit less than the water activity. And so in this case, in the model, what I input was a 70% relative humidity. I put a temperature of 30.1 degrees Celsius, 86 Fahrenheit, and I started out the initial moisture of 4.5%. Now, if you adjust that initial moisture and you put it lower or higher, the curve will look similar. It'll just take a little bit of time to reach that equilibrium moisture. But in this case, what it showed us is that we're going to have a predicted moisture of less than 6.5%, and it reaches that point pretty quickly. I think it's about 10 days or so. It's going to reach that kind of that maximum moisture. So we can do this. We can look at data that we have on shipping, and we can start to plug in these different conditions and tell us, what is that maximum potential moisture that those almonds could reach if we assign a maximum humidity and temperature. And then we can go back and we can look at the data to see, what are the inhibitory factors for the mold growth and aflatoxin development to tell us if we think we have a problem with mold growth or aflatoxin development during transit. And we've done that. We've looked at a number of different shipping routes. We've conducted a number of different studies over the years where we've placed data loggers into different into the containers, in pallets in different locations, collected that data, and we've looked at it. Now here's an example of a study that we did in 2021. This is product that went to Japan from Oakland to Tokyo. And the right axis here, and I know it's really small, but what that's humidity and temperatures on the left, and the green bar on the top is humidity, and the blue or the purplish is the temperature. What we saw in this particular case, the worst case conditions, so I took the highest values that we achieved. So the temperature was 30.6 Celsius, 87 Fahrenheit. The maximum relative humidity that we actually reached was 61.9%, and we saw this actually at the front end. So when it was loaded at the port, or before we even got on the ship, that's when you typically see these big temperature fluctuations and humidity fluctuations. It's before it gets into the ship, and then you have a buffering effect that happens once it gets on the ship. But when it's sitting there on the dock, that's when you're going to have that temperature and humidity abuse or pressure. And then our maximum, yeah, I mentioned the maximum temperature. So in this particular case, then we can plug this data into that model that I just showed you. In this particular case, we never reached a moisture greater than 5.4%. It was actually about 5.3%. So then we can go back and we can equate this to the water activity using the isotherm curves, and this very clearly tells us that we don't have any issues with the potential for mold growth or aflatoxin development. So once we have the final piece from Dr. Gizachew and we have a publication that clearly identifies what is that minimum water activity that allows the molds to grow and produce aflatoxin, this will be very powerful as we're working with regulatory agencies across the world to overlay the shipping data that we have, the temperature and humidity data to really show that shipping isn't an issue as far as almonds are for mold growth and aflatoxin. Now, controlling at the front and the tail ends, that's where it becomes a little bit more important. But the shipping routes themselves really aren't an issue. And I think that's all I had. We're going to switch gears here a little bit and talk about another area that's kind of new and ongoing.
Good morning. In addition to aflatoxin, the AQFS committee been funded the research project. We also pick up a couple of small items we're working on. So I'm going to share with you what we learned from the small two projects. One is MOSH MOAH. Other one going to be almond oil composition. So what the MOSH MOAH? MOSH is just a short term for the mineral oil saturated hydrocarbons. So it can be any straight chain, branch chain of a series of saturated, the hydrocarbons. Could be cycloalkyne or straight alkyne. So this mineral oil issue is picked up by European Food Safety Authority. They definitely pay attention to those issues more than other countries, and more sensitive, because they carry out a risk assessment about both, the mineral oil. There's two types of mineral oil. Other mineral oil type is called aromatic hydrocarbon. Those is with a unsaturated bond, the double bond with the aromatic ring. So those with a different, structure of various number of rings. You can constitute different type of MOAH, compounds. Those are called MOAH. So the assessment the risk assessment carried out by European Food Safety Authority. They look at the exposure potential. They conclude that MOSH does not pose any, risk to the public health. So they haven't set any limits. But they found out that one of MOAH compounds have pose some potential genotoxic risk to the human being. So they set up some limits for MOAH based on the oil content of a food. The higher the oil content, you have the higher limit. For almond, we have like anywhere between 48 to 45 to 50 some percent. The oil content depends on what variety. So the average about the 40 or 50%. So based on that, we probably should be considered less than 50% would be 1 ppm, or if the fat content above 50% would be probably 2%. That's for MOAH, okay? So and then we did some our own assessment, and then did some quick survey, and then now it's doing the more comprehensive survey. So basically, based on our assessment, the potential contamination for mineral oil would become from three sources: environment, from soil contact, and that's because you drive the tractor through, there's some oil dripping, potential oil dripping to the ground. Those could have contact. And other sources would be, process and line from the lubricant use, those kind of accidental contact with on the conveyor belt. And the other one would be some contact with a carton box. You pack the product in those recycled cardboard cartons. Those are three sources. So we did a quick survey in 2018. We out of how many samples? It's 25 samples. We only found 3 samples have a detection of level of MOSH. So and then we will say we're going to do a more since there's more and more handlers get the inquiry from the European buyers about our statement, our fact about the mineral oil. So we're started more comprehensive survey. With this, in their survey objective is really trying to understand the prevalence of mineral oil, or understand the contamination source of mineral oil. So we designed a project, look at the more samples, 60 samples from incoming almond, target the potential contamination level from orchard ground, from oil contact, for soil contact, and then 30 samples from manufactured product, trying to see what's a potential contamination from lubricant, from processing line, and then 60 samples from finished product for the product being packed in the carton boxes, been sit there for several months. So that's how our design. The project's still ongoing. We have a first batch of sample complete. This is like 36 sample. Out of those, most of those are manufactured product. So you can find out that we have found that no MOAH in all 36 sample. Also from our 2018 survey, there's no detection of a MOAH. And then most of those from the first batch of 36 sample, out of 12 of the samples come from manufactured product. So those are blanched product, blanched slice, diced flour. So those gone through multiple stages of processing. So we did find out some MOSH. So those MOSH has a different compounds. Some sample have some head. Some sample have up to 4 MOSH samples. But we also found that there is no, out of a 4 initial sample in a finished product, sit in the box, sit in the woven bags, so there's nothing there. And then we have a finished natural almond, like 4 of 16, found that some positive hits on the MOSH. But those 3 of 4 come from the sample sit there for more than a year. So that indicating that the carton box have been probably from recycled cardboard box. So those have contaminated with ink. So there is some potentials. So thinness, you heard from my previous slide, European have limits for MOAH, but we haven't found a low MOAH in our sample. European have no limits set for the MOSH. We found a very low level of MOSH. So we have about the, over 100 samples to collect to continue to finish the survey. So hopefully we're going to have the same trendy data can be gathered, but then we're going to generate the fact sheet for industry to share with our European buyer. Hopefully the information going to stay the same, so we have no issue with the mineral oil contamination. So now I'm going to move on to the next one for almond oil. Almond oil, basically, this issue brought to us by almond oil company. They raised to AQFS committee. So they raised the concern about almond oil being adulterated by, other seed oil, because they, such as high oleic acid, the sunflower oil. So those prices are cheaper. So this is only talk about the refined oil from recovered from the byproduct. So because almond oil has been handled, treated as a very minor portion of our business. It's a recovered product from those upcycled byproduct, or could be from the out-of-spec good product, but those been without much value, without much attention from our industry. But as now our industry more members creating more innovative ingredients such as a D-fat meal, high protein powders, they will generate some oil. So those oil from good almond, good quality almond, those oil deserve better attention, better use, offer much better quality. So those, we cannot treat those as the same as others. But also, so we look into it. So we want to find a better value for this oil, for almond oil in general. So that's why we, ABC staff, take on the challenge, to look at it, did our own data analysis, and also consult with the stakeholders, and form even a task force to discuss the issue, what our next step should be. So that's how, we have there is no information, no solid data to differentiate different type of almond oil made from different feedstock. So that's why we look at, there is some standards available, but those standards are really focused, made for the refined oil. So the limits are either too wide or too low to really value the oil made from good almonds. So we have formed a task force with 9 members. We had the meeting in November. So there's some consensus we made out, a recommendation come from the task force. So definitely, we, based on our current information, we wanted suggest us to produce a high-level fact sheet to share with the stakeholders and to post on the website, ABC website, and also created the insert for technical kit to showcase almond oil as a typical regular almond form, so that can be recognized by user. Almond oil, if most people thinking almond oil from byproduct been used for cosmetic, but actually after goes through a refining process, it's good as other oil can be for dietary application. So we really did showcase potential use, good use of almond oil. So, but at the same time, we come to agreement at the current time, President, we probably should not pursue to establish internal or industry standards, because there's already available standards to reference. Also, maybe allow the market to slowly to develop, for the different source of oil, like, you can call virgin oil, the cold press oil from the refined oil, allow the market to develop. And then the task force does have a couple requests to the board, want us to really look at industry, to look into it, to invest in the research, and to promote a health benefit of almond oil, so that the consumer or food industry can recognize almond oil as a good ingredient to use, and also what benefit, what functionality can the almond oil offer. So also start to educate or market users of almond oil. So industry, oil company normally do the composition analysis based on fatty acids and phytosterols. But that's probably for the authentication purpose, we recommended to add the tocopherol profiling testing in there to make it more confirmatory, to differentiate the good quality almond oil from refined oil or from adulterated oil. So this is what we already discussed with the committee, but I want to show you a few things about some facts we learned through the process. So there's two streams of oil, almond oil produced. So like I mentioned, primarily, currently, come from the recovered product from the upcycled byproduct. So those normally have to go through probably refining process, and then we commonly mark as refined oil. And then other new stream of oil come from defatting good quality almond for the defat meal or high protein powders. Those use the good almond, and then those probably they might go through similar process or different process, could without heating, but they might or may go or may not go through the refining process. So basically, the oil, refined oil from byproduct may use the degraded byproduct. So their quality probably different. So in a different source of a feedstock, different process, going to affect the composition quality of almond oil. So how to differentiate those? So industry need to look into it. So from our research, our data analysis showing almond content, out of the last 2 or 3 years of our current 15 major varieties have an average about 48% of fat. Out of those fat, probably, basically all oil contain 3 major components. Fatty acids are primary one, and then there's a minor one called phytosterols or plant sterols. So this is the minor one in the milligram per 100 gram level, and the tocopherols. So those are the very minor components, but it's important, very crucial portion of plant oil. So the almond oil have a very, the fatty acids in almond oil is dominated by oleic acid, followed by linoleic acid. So there's some acids, not absence of several, those long chain fatty acids make it almond oil unique. But those actually you can be commingle or blended with other oil to match up with fatty acids profile. But if the person was trying to match up, they can maybe make up some oil to match the fatty acids profile almond oil, but they probably gonna have hard trouble to match exact profile of a phytosterols or tocopherols. Phytosterols are really dominated by beta sitosterol, and then with the absence of a brass casterol, as make an almond oil unique compared to other plant seed oil. And the other one is almond is very famous for the tocopherol. We have a high tocopherol. Tocopherol is most important. Tocopherols have several forms. Most important ones are alpha tocopherol. Over 95% of tocopherol in almond oil is alpha tocopherol. Those are the most biological potent tocopherol. So they make almond oil very unique. So this is basically based on the composition of almond oil. Almond oil is very high in oleic acid, moderate in linoleic acid, or palmitic acid, or low in stearic acid. It's in terms of the fatty acids composition-wise, it's very comparable to olive oil. So if a consumer value olive oil, they should value our almond oil same way. So in my simple comparison, almond oil is actually should, in terms of the tocopherol profile, even better than olive oil. So that's why we shouldn't really starting to pay attention to almond oil to create some value, create some awareness to elevate the value of almond oil. So high percentage of beta sitosterol and then alpha tocopherol, or absence of a certain tocopherol and sterols, and then some minor fatty acids make almond oil distinguishable from other plant oil. And the percentage of individual components become a very good parameter to differentiate almond oil from other seed oil. But the actual level of tocopherol or some tocopherol and phytosterols, So it's good, reliable tool to differentiate the quality of almond oil from those the low quality oil and then from the adulterate oils. So that's good for authentication. So we look at there is quite many standards available. There's Codex, there's European and US pharmacopoeia standards, or have a focus on refined oil, also focus on fatty acids profile, and then the phytosterols. So those are in terms of fatty acids profile, quite comparable. They're almost identical between different standards. But Codex does have a set of the level for tocopherols, but those is designed for the refined oil. The limit range is too low, too wide, and no limit is too low. It's really you cannot use for differentiate the almond oil from good quality almonds. So this is a European standard. European pharmacopoeia have a differentiation for the refined oil or virgin oil based on 3 phytosterol difference. So this is but they don't have tocopherols. But based on our data, we generated a range of those for each of those essential components. We feel the almond oil have a good offer good tool to differentiate good quality almond oil, differentiate almond oil from other adulterate oil or other plant oil. So we suggest to use both of percentage and actual levels. We just had to request the lab to report in both ways. I don't think they're going to add additional cost. It's just same testing, just report different format. So that's what we have. Those we're going to generate the fact sheet based on those. So that's basically we will hopefully very soon with a further input from industry members, we're going to generate a fact sheet to share with the almond. I want all of you sit there, to be aware almond oil is good oil. In the future, there's more oil produced from good quality almond, deserve our attention, deserve better value. Thank you.
Thank you, Guangwei. We have a few minutes, so I'm happy to open it up for questions. We covered a gamut of issues today from the older... after Q&A? After Q&A, okay. So we'll take a couple quick questions first. So if you don't mind, Dr. Gizachew, I have a quick question related to aflatoxin. Do we know in the life cycle of aspergillus growth when aflatoxin is actually produced? Is it part of the normal growth, or are there special conditions that may generate aflatoxin?
It seems like actually the conditions are more important. We've seen not on almonds but other oilseeds within 5 days you can see aflatoxin produced. So it seems like the nutrient component of the substrate, we call it, like for example whether it's almond or oilseeds, that seems to determine the number of days that aflatoxin that can be produced by that particular fungal species.
Okay, thank you. Do we have any other questions from the audience?
We have a speaker. Yeah, you can. We have micro here.
I think I see Themis is here.
Yeah, I say we have a micro.
Oh, microphone. Okay. Oh, Themis, would you mind stepping up the microphone? Another one of our aflatoxin researchers.
Yeah.
Yes, Dr.
Okay. I noticed that in your inoculations of almond kernels, you get a lot of Rhizopus and Aspergillus. Do you sort of sterilize these kernels with chlorinated water, and for how long?
No, we don't actually. We received the almond from our colleagues. Guang sent me the almond samples, so we didn't sterilize. We assume they were sterilized, so we didn't sterilize them. I think
Those almond being pasteurized by PBO.
Yes, but still, there is a lot of contamination of Rhizopus. Probably, I'm not sure if you know that Rhizopus and Aspergillus niger are major pathogens that cause whole rot. So there is a lot of contamination with these fungi. It's, I think, to get clear results, those fungi should be out of the picture.
Those samples being pre-treated by PBO, maybe it wasn't complete wipe out, but that's a sample we prepared.
That's right. Yeah, I suggest that we should do that. That's why it was interesting to see the cross-contamination.
Thank you. One question for Tim. Have you ever checked kernels that come from mummies? Which are intermixed with a good product? Those have very high levels of damage by nevalorgium, and also the kernels look very dark, and probably it's good to those to be removed before the product is processed. I mean,
Absolutely. In this particular study, we didn't, but we have done some work on that in the past and found concentrations of aflatoxin in the mummy nuts. So that's a great point. That's definitely something that the handlers, processors need to address, coming in, because you do have the old mummy nuts that were pulled in, and you can see it, in the hauler shellers, I think, start to remove the mummy nuts, but that's something the handlers need to be aware of throughout processing.
I had a quick question on that. Are you guys going to be doing some of the work, you mentioned we're trying to put that aflatoxin in the orchard. Are you working with some of the atoxigenic strains that they've developed for?
I think that's a good question. I have to talk to my colleagues.
One project, out of a project, I think this potential area worthwhile to
Yeah.
look at. We haven't shared with him what other area we haven't looked at.
We try to at least get isolates and see what happens, but good question.
Okay. All right, we have one more slide?
Yeah, that's him.
One more slide?
Yeah. One more slide, one invitation. So you guys be patient, okay?
All right, we have a special researcher here today, and we want to welcome her to do one quick presentation. Are you gonna have a poster at?
Yes,
Yeah.
I also have a poster session.
Okay,
So it'll be quick.
please go ahead.
Thank you very much. Hello, everyone. My name is Han Chen. I am a PhD candidate in the Food Science Department from Purdue University. So today, so I'm inviting you to participate in our study. We are working with ABC to conduct an interview with the food safety managers or supervisor from the almond processing company. So what our goal is to learn about your experience in training or communicate food safety with your employees. So our goal is to try to identify the gaps and needs to in the current food safety training, and also we want to provide suggestions for developing and improving food safety materials for the almond stakeholders in the future. So the interview will be up to 1 hour, depending on how much you are willing to share. So if you're interested in participate, you can scan the QR code to sign up. And I also have some flyers here. So if you know someone you think they might be interested in participate, I can also give you some flyers so you can help me to share the study. And I will be here after the session if you have any questions. Thank you.
Thank you very much, Han. So please help out with that research, your opportunity to participate.
Because they're out of one USDA big project. They go through this exercise. They were trying to help us to develop some food safety training curriculum. So what the input you can give can help them frame the better design of curriculum. So it's very good. We're really enjoy to work with them. We can enjoy some funding, federal funding, from this to develop some good education material.
Thank you very much, Guangwei. So we're ready to wrap up the session today. I know our presenters will be around, happy to answer questions anytime. Just a couple reminders. The food trucks are here for lunch. The next presentation starts at 12:30. And be sure to attend the annual State of the Industry at 2 p.m. in Ballroom A, I think right across the hall here. Almond Board Chair Alexi Rodriguez, outgoing CEO Richard Waycott, incoming CEO Clarice Turner, along with a few other special guests. So, look forward to that. And want to thank you again, and hopefully you enjoy the conference. Thank you.
Thank you so much. That was good.
Yeah.